Good morning, myself Gangara Mandloi. I want to introduce about the mechanical property of the materials. The learning objectives of the mechanical properties is the student will be learn the behavior of the metal under the various load conditions during the specimen test. The key concept about the mechanical property, the student will be able to concept of the stress strain, standard tensile specimen, engineering stress strain, elastic and plastic deformation, tensile test, determination of the proof stress, ductile and brittle fractures, true stress strain curve, toughness of the various materials, and ductility and brittle fractures. The tensile test you can see here. This is the shape of a specimen in a cylindrical form. Here, dotted green color of the specimen when load is applied along the axial, along the tangential, then diameter is decreasing and length is increasing. In figure B, you can see that here when load is applied, here dotted area and compressive load, then length is decreasing and diameter is increasing. And figure C, here you can see that as a shear stress, here it is the shear between the two surface, and torsional stress you can see that here the tangential force is applied here. Another you can see that here this is the tensile test machines in which your specimens is hold between two jaw. This is the specimen, standard tensile specimens. This is the gauge length 2 inch. Here is the reduction cross section at 2 and 1/4 inch. Diameter is 0.55 diameters. This is the standard size of the specimen, and you can see here in large view of the specimen. This is the square thread here, and this is the specimen is hold between here, and extensometer is used to measure the strength here. Energy engineering stress is the force on upon the original cross sectional area. Similarly, is engineering strength we can calculate the change in length upon original length. It is also denoted by LL upon original length. This is the elastic deformation. Here stress is along the vertical axis and strain is along the horizontal. The stress is proportional to the strains when load is applied, and here this is the slope equal to the modulus of elasticity. This is the deformation. At the point P, stress is directly proportional to the strain, and after the P load is released, then material is permanently as a deformations. Here is the upper limit of the yielding point, it is the lower limit of the yielding point. You can see another stress strain diagram of ductile materials. This is the tensile test diagram. You can see this from this point to this. Here is the specimens. After this, you can see that here from this point. Here is the some plastic deformation, means increasing length. Here is the start to necking, and then at the point of start to fractures. Here it is the stress strain diagram. Here is the A, at the point A, proportional stress. At the point B, elastic limit. At the point Y, here is the yielding stress. Here is the ultimate tensile stress. At the point F, material become fractures. This is here is the this is the various properties of the materials. Another you can this is the diagrams. Here proof stress. It is the point where the strain line intersect the stress strain diagram and consider as the proof stress in order to work here. We can draw the point line here parallel. This is the proof stress. Another figure you can ductilities you can calculate here, and release stress is also we can calculate toughness of the material, brittle material. This is the diagram for the brittle material. This is diagram for the ductile materials, and toughness of various material here. You can see the high carbon steel is the strongest, and medium carbon steel is the toughness, and low carbon steel is the most toughness. This is the true stress strain curve. Stress strain diagram for the mild steel. This is the true stress curve, and this green curve, it is the engineering stress curve. Stress is force upon, strain is the force upon area, strain is the in long of Li upon Lo. This is the another formula here. You can ductile material and fracture material. Ductile material is more elongated, and fracture material become the brittle. The brittle material, and here is the ductile materials. You can see that here is the necking formations. When load is applied, it start to decreasing the diameters. This is the various figures. You can see that here. Here is the necking ductile material fractures, and this is the brittle material fractures. This is the comparison between ductile and brittle materials. You can see that the various